So what we have, we should prove that this argument is invalid. P implies Q, not P, and conclusion. What's conclusion? Not Q. Not Q. We should prove that this argument is invalid. For this, we will construct truth table, and we need only 4 rows because we have 2 variables. Let's be true, true, or let's denote by 1 and 0. It's more easy for me. So 1, 1, 1, 0, 0, 1, 0, 0. Okay. Here we have P implies Q, not P, and not Q. Okay. Now, P implies Q. When this implication is proved in 3 cases and only in 1 case. And do you remember what was this case?
Then a necessary condition is false.
Yes, when P is true and Q is false.
Yes.
Here we have false and other. By definition, we know it by definition of implication. Do you agree? Look critically. Do you agree with this?
Yes.
Okay. Now, not P. Not P, it means 0, 0, 1, 1. Not Q. Is it correct? Not P?
Yes.
Okay. Now, not Q. Not Q. We have 0. But before find the values for not Q, we should first identify what are here premises. What are premises here? We have 2 premises. P implies Q and not P. And what we need now to identify critical rows. Here question was on the chat that why we here, when P is false, we have 1. You can see definition of implication, and this is by definition of implication. And why this definition? Do you remember about promise, about case of promise? So now, how many critical rows we have?
2.
We have 2 critical values. When both premises are true, and premises we have here, they are premises, and critical rows, they are critical rows. They are critical rows. And now let's find value of NAT Q. We don't need to find value of NAT Q in first two rows because it does not matter for argument. Is argument valid or invalid? What does matter? It's critical values when both premises are true. And what can we say about this value? What we have here, NAT Q?
0.
Not Q. Here, Q is here 1, so Q is here 0. And what about last row?
1.
Here is 1. So in the one critical row, we have 1, but in another critical row, we have 0. So it means that our argument is invalid. Any questions about this? Ask by microphone. You can switch on microphone and.
But we could see it from the beginning that it was invalid.
How?
No? How? Because P implies Q and not P. Not P doesn't mean not Q. If
Yes.
it were not Q, then it could be
Yes,
not P.
I got it. You are almost right. But to prove, only way to prove it's truth table.
Okay.
Okay. Now next. Okay, and now let's number A. P implies Q, P. We should prove again that this argument is invalid. Any idea? Write down, and then I will write down correct answer, and we will compare.
What was the question?
Construct truth table to prove, in the case A, prove that it's invalid argument. And we should construct truth table and construct it independently, and then I will write down correct answer. And then
we don't see the exercise.
Sorry, just a minute. Okay, I will write down here. P implies Q, P. We should prove that this argument is invalid. So again, we will construct truth table P, Q. P implies Q, and P. here we have the same values, 1, 0, 1, 1. And, oh, sorry. I make, no, always is, all right. So we don't need Q column because Q is here. And we can just copy 1, 0, 1, 0. So their premises these two rows are premises, and we need to identify critical row. Critical row, we have first,
third,
and third, absolutely. And only in these rows, we need to find value of P. And P here is 1. It looks okay. We don't need to identify critical value here. And also we need to find critical value of P, and it's 0. So in the one critical row, we have that conclusion is false, and it means that argument is invalid. Now I will give you example. P implies Q, not Q, and conclusion not P.
this is right.
This is right, yes, we know it because it's modus tollens, but we did not prove it. And let's prove it now. So we have P, Q, P implies Q, not Q, and not P. 1, 1, 1, 0, 0, 1, 0, 0. P implies Q, 1, 0, 1, 0. Now not Q, 0, 1, 0, 1. And we have only one critical row. This one, critical value. And now we don't need value of conclusion here. We don't need here, and we don't need here, conclusion. And here, in the last row, what is not P? We should look to P. P is false. It means not P is true. And conclusion. Conclusion that this argument is valid. Now here we have a very interesting problem about computer program. I will show it. It's problem number 66. Can you see problem? Can you see problem?
Which one?
36.
Yes,
36.
now.
This one. We have to find mistake in the program. I would like to recommend that denote these statements denote by variables. And to not confuse, let's denote there is undeclared variable. Let's denote it by U. There is undeclared variable. And please write down it. There is undeclared variable. Let's denote by U. There is syntax error. Let's denote it by S. By first letter of the statement.
It's undeclared variable.
What is Nino?
Uh,
Undeclared variable. So you think error is there is undeclared variable. Maybe, but let's denote by variables and solve. It's your hypothesis, or you can prove it. Okay, let's continue denotion. If there is the first 5 lines, there is a missing semicolon. Let's denote it by M. Missing semicolon. Let's denote it by M. And the last statement, misspelled variable. There is misspelled variable. Let's denote it by V. Let's denote it by V. And now, let's now write. Now I will share again my phone. I hope you write down these statement forms. So first statement form is U or S. Second, S implies in the parentheses M or V. Third, not V. And fourth, not M. Write down it, please. And now I will share my phone. So I wrote down our statement. First one, U or S. Second, S implies M or V. Next, not V, not M. And now, let's now solve
Undeclared variable.
maybe. But let's now show how to solve it. First of all, from the last two statements, we can say that not V and not M. Do we agree? Because we know that not V, not M. Do we remember generalization?
Yes.
Both are true, not V, not M. And we can say that it's not V and not M. And now we can use De Morgan's law, and it equals not V or M. By De Morgan's rule. Okay. Now we know that S implies not V or M. What it means?
S is false, like there is no syntax.
Absolutely, very good. So it's given that S implies M or V. S implies M or V. But we know that true is not M or V. It means that we have not
Not
S. S is false, so not S is true. Not S. Now, again, generalization rule, we have U or S. But also we know that not S. So we have not S, and here I will write U or S. We know U or S, not S. And what it means, our conclusion? Our conclusion, it means U.
U.
So you are absolutely right. This is correct answer. Undeclared variable. Okay, if any questions, you can ask. If no questions, I will write next
the
problem.
proof is proof because the U is true. The value of U is true. That's why the conclusion is also true, and the answer is U.
Yes, yes,
Huh?
yes. I agree. Now, let's now check. I will write down argument and let's check. Let's check this argument is valid or invalid. P implies Q. Can you see my whiteboard?
Yes.
P implies Q. Q implies P, and conclusion. P or Q. Okay. So our time is finishing, and let's hurry up to construct truth table. P. So I will upload these materials and also
No, it's false.
it's false.
Right? Yes.